We're going to want to explore how we can learn to multiply polynomials in these series right here. So to do that, let's remember what repeated multiplication looks like. If we had a 2 times a 2 times a 2 times a 2, we decided that there's a way that we can write that in a shorthand form, and that was 2 times itself to the fourth. So we introduced exponents. Exponents in this case is a 4 to this, and the base is a 2. What would happen then if we did 2 to the fourth times 2 to the third? What would that result be? Would it be 2 to the 12th? Would it be 2 to the 7th? Would it be 2 to the first? What would it be? So let's understand what we're asking to do. Remember, 2 to the fourth is a 2 times a 2 times a 2 times a 2. Now we're going to multiply that by 2 to the third, which is a 2 times a 2 times a 2. If we multiplied all that out, notice that we have a repeated multiplication. All are the same base, and I'm multiplying the base to itself 7 times. So it appears that 2 to the fourth times 2 to the third is also the same as 2 to the fourth plus the third, 4 plus 3, which equals 2 plus 7. And that's a rule that we can use as we're multiplying polynomials, and we have to think about their exponents. So exponent multiplication, we multiply, we keep the base, we add the exponents. That only occurs when we're asked to multiply these terms. So let's look at a couple examples. So 2 squared times 2 cubed. Remember that equals, since the bases are the same, we add their exponents. Equals 2 to the fifth. What do we have? X to the 7th times x to the 9th. What do we need to notice first? Well, we notice that we have the same base. It's x to the 7th, x to the 9th. Now, you're right. These are not like terms. They're unlike terms. But when we're multiplying, what we care about is that the base is consistent. So they're both x's. And if that's the case, we add the exponents. So we get x to the 16th. This is x times itself 7 times x times itself 9 times, produces x times itself 16 times. Let's change the base. Let's make it y times y to the fifth. What do you make of that? Well, is there an exponent with this y? Is it just a 0? No, remember, if there's no exponent there, it's understood 1. So this becomes y to the 1 plus the 5, which equals y to the 6th. And I hope that makes sense. We have y times y times y times y times y. We have 6 y's we're multiplying to each other. Well, what if we have something, let's have z squared times z to the fourth times z to the third. Can we do it 3 terms? Sure. Notice that all the bases are the same, which is one of the requirements. From there, let's add their exponent, which is a 2 plus a 4 plus a 3. And my result is z to the 6, 7, 8, 9, z to the 9th. And to give this illustration a name, we call it the product rule, which states that if I have some b to the m times some base to a different exponent, I maintain the base and I add the exponents. It's called the product rule that we use here with our exponents.